budgeting. So first steps that we need to estimate cash flow first, inflow or outflow, and we need to assess the riskiness of these cash flows. Then we may determine the appropriate cost of capital. We have done to talk about the third step. And then we will talk about fourth step and fifth step in chapter 12. Today we will cover those kind of topics so that we will talk about several various way to estimate the capital budgeting, whether or not we accept. Okay, so the various methodology such as NPV, IRR, payback period, something like that. So we will talk about mainly the decision criteria. And then if the present value is higher than 0 or IRR is higher than AACC, then we can accept those kind of project. So I already let you know independent or versus mutually exclusive project, normal or non-normal cash flow streams. So here you go. Decision criteria. We have broadly, we have three kinds of decision criteria. NPV stands for net present value. IRR means internal rate of return. But as you shall see, IRR has a lot of the crucial flaw. So instead of IRR, we need to use the modified modified IRR. This is MIRR. And the payback period provide a very ballpark estimation. So very simple method. So we will talk about payback period and discounted payback period. Discounted payback period reflect the time value of money. Okay, so we will talk about those kind of decision criterion in this class. Okay, so basically, the decision maker used to use NPV or IRR or both of them. Okay, so NPV or IRR. So most of the decision maker use both of them, NPV and IRR. Which one is better? You can see, you shall see. So let's take a look at the NPV first. NPV is net present value. Net present value is sum of the present values of all cash inflows, cash outflows of project. So we can calculate that present value of all cash flow that happens during the project. So the zero as of today, 1 year later, 2 years later, 3 years later, and n years later, n is the terminate date for the project. So just calculate the present value, reflecting time value of money. That's it. That's the net present value. But the important thing in that to calculate the net present value is the R discount rate. This R is WACC. So be careful, we should use WACC as the discount rate in NPV, net present value. The fact that we use NAACC as the discount rate means what? Reinvestment rate is assumed to be WACC. Okay, so if we at 3 years project, cash flow at 1, cash flow at 2, and cash flow at 3. The fact that we need to discount WACC means we can reinvest cash flow during the project can be reinvested at WACC, the same meaning, right? So we can calculate the present value of each cash flow that happened during the project. This is present value of cash flow at 1, present value of cash flow 2, present value of cash flow at 3, which is same as what? This cash flow can be reinvested. if we receive the cash flow at time one, then this cash flow can be reinvested during the first year and second year. During the second year and third year, this cash flow can be reinvested at AACC until the maturity of this project. The same meaning, okay? So the fact that we can use the AACC as discount rate is same meaning as the fact that the AACC, I mean, we can assume the reinvestment rate is AACC. Okay, so anyway, net present value is the all of the present value of cash flow stream during the project. That's it. So here you go. There are two projects we will consider, Project S and Project L. Project here you go. Project S cash flow stream is the first of all we need to expand, right? So that this is capital expenditure, capex, capital expenditure. So to conduct this project, we need to spend $1,000 at the starting point, starting time, and we can receive the $500 at time one, $400 at time and at the end of second year, $300 at the end of third year, $100 at the end of fourth year. Then we can calculate the present value of each cash flow stream. So $1,000 at zero is $1,000 as of today. $400 at time one can be calculated by 500 divided by 1.1, right? If we assume the AACC is the 10%, we already figured out 10% of AACC in the cost of capital, chapter 11, right? So we already figured out AACC was 10%. So if we use the 10% of AACC, then the present value of cash flow at time one is 454.55 because 500 divided 1.1. How can we get the 330.58? 400 divided 1.1 square. How can you get the 225.39? 300 divided by 1.1 to the power of 3. How can you get the 68.3? 100 divided by 1.1 to the power of 4. Then that's it. And if we sum of all kind of cash flow as of today, reflecting the time value of money, then net present value for project S is a $78.82. The unit is the different, but anyway, it doesn't matter. By the same token, NPV for project L, then it's that can be calculated by 100 times $100.4. So cash flow stream in project L is the capital expenditure is same thing as the project S. This is project S cash flow stream. Project L's cash flow stream is $1,000, and 100 we will receive at the end of first year, $300 at the end of second year, $400 at the end of third year in page number 442, table 12.1, 442. And the last year, we are supposed to receive the $675. Okay, this is the project L's cash flow stream. So as you can see in project S, we will receive the more money in earlier time, right? Earlier time. Whereas in project L, we will receive the money mainly in later time, right? Later time. Okay. So the the period that we will receive is different or as in project S, we will receive the money relatively earlier, whereas in project L, we can receive the money in the later, right? So this is the reason why I exaggerate this factor is because as you shall see, there's some there's some conflict to make decision, as you shall see. I will explain later on. Anyway, so the net present value for project S is $78.82. Net present value for project L is $100.4. Then which project should be accepted? It depends on the project is independent or mutually exclusive. So basically, net present value can be calculated by present value of all inflows minus cost. It's going to be net gain in wealth. So if project independent, except if the project net present value is higher than 0. So we can accept the project whose net present value is positive if projects are independent. Okay. Whereas if projects are mutually exclusive, then we need to accept the project with the highest positive net present value, those that add the most value. So in this example, accept large project if mutually exclusive. If projects are mutually exclusive, because the net present value for project L is higher than net present value for project S, and we may accept both of them if two projects are independent. Okay, so that's MPV. That is very simple. Then let me show you easier, more simpler way to calculate the net present value by using Excel spreadsheet. Here you go. Project S, project L. So times 0, 1, 2, 1, 2, 3, 4. This is table 12.1, page number 442. The project S capital expenditure is negative $1,000, 500, 400, 300, 100. Whereas project L's cash flow stream is the cash flow, cash outflow is the identical with the cash outflow in project S. 100 at 1 time 1, 300 at time 2, 400 at time 3, 675 at time 4, right? So the function name to calculate the net present value is NPV. Wow, it's so simple, right? NPV. So let's find the function name of NPV. Here you go, net present value, NPV. Then rate. We need to know the AACC, right? So AACC. For example, here you go. And the value, A4. .1. This is AACC. So if AACC is assumed to be 10%, we already figured out 10% by using the previous example in chapter 11. AACC was 10%, right? So NPV, the project S, NPV and project L. So the function name is NPV. Here you go. So we need the information of the AACC, discount rate 10%, and the value is from today, the cash flow that happened, today's cash flow, and the cash flow that the terminate date. Just drag, click and drag. That's it. So if you confirm, then $72. How about the net present value of project L? Net present value, rate 10%, value, just click and drag. That's it. Uh-oh, but this number is different. We drove. Uh-oh, something wrong. Uh-oh, 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 uh-oh. So it's error. So Excel spreadsheet is so smart, but less smarter than you. So human being are more smarter than Excel spreadsheet. So Excel spreadsheet recognize the when we calculate the net present value. Net present value function key recognize the first term, first cash flow happen at the end of first year, not equal zero. So by definition, but I mean automatically in Excel spreadsheet, net present value recognize the first cell as the cash flow occurs at time 1, not time 0. Okay, so be careful to use the net present value function key in Excel to use the Excel spreadsheet. So let's do again. Net present value interest rate is 10%, and you cannot start the time 0, but you should start time 1. Here you go. Okay, not start from time 0, but start from time 1. That's the net present value. So by definition, in Excel spreadsheet, automatically net present value NPV function recognize the first cell as the cash flow occurs at the end of first year, not 0. Okay, so click the confirm, and then you need to add the capital expenditure that happened as of today. Then the answer is $78.82. This is identical that we already drove, right? So $78.82. Net present value for project L, by the same token, interest rate, I mean the WACC is 10%. You should start not 0 at time 0, but time 1 to mature the until the closing project day. Click, and then we need to add capital expenditure cash outflow as of today. Okay, so the net present value for project S is $78.82. Net present value for project L is $100.4. So be careful not to start the cash flow occurs at time 0 to calculate when you use the NPV function in Excel spreadsheet, right? So this is correct answer, right? Okay, that's the net present value. So present value of inflow. Anyhow, this one is this value is the NPV in Excel spreadsheet, right? And then we need to consider the cost, capital expenditure, cash outflow, right? That's the NPV. Then next, the method to estimate the project is IRR, internal rate of return. This is return, right? Internal rate of return. IRR is the discount rate that forces present value of inflows equal to cost, right? So, which means discount rate that makes NPV equals to 0. IRR is the discount rate that makes NPV equal to 0. So how can you calculate this one? That's 0, right? 0. So all of cash flow divided by cash flow that happened at the end of first year, second year, even the as of today, right? Today is the cash outflow generally. That thing should be discounted by 1 plus IRR. Plus IRR. So the most different point between NPV and IRR instead of discount rate. In IRR is used as the discount rate, right? IRR. Whereas in NPV, WACC can be used as discount rate, which is the most different thing, this different point between NPV and IRR. As I told you, the fact that we use WACC as discount rate means that to calculate the present value of each cash flow stream that happened during the project, WACC, that cash flow should be discounted by WACC. Simultaneously, we assume that the cash flow can be reinvested at WACC, right? By the same token, if we use IRR, we assume that all of cash flow can be reinvested at IRR, okay, which is the most different thing between NPV and IRR. So if we calculate the IRR and IRR project L and project S, project L's IRR is 13.55%. Project S, the IRR is the 14.49%. It's impossible to calculate by your hand, not impossible. If we have 2 years, then you can solve it because this is quadratic equation, right? Quadratic equation. But if we have longer than 2 years maturity, 3 years, then it's impossible. It's almost impossible, right? 4 years, 5 years is impossible, right? So if we conduct this class on offline, then those kind of questions cannot ask in exam, right? Because it's impossible, right? But our class is being conducted online, right? So you can use the Excel spreadsheet in the exam. So if we use Excel spreadsheet, you can solve the IRR. How come? Let me show you. So by the same the example, IRR S, IRR L. So to calculate the IRR by using Excel spreadsheet is much easier than to calculate the net present value by using the Excel spreadsheet. So what is function name of to calculate the IRR? Just IRR. So simple, right? IRR. So value, click the zero, the cash flow as of today, and then you can just drag all of cash flow. That's it. Wow, so simple, right? IRR value, click the first cash flow, not like zero cash flow at time 0. Just what you should do is just drag. That's it. So project S IRR is 14.49%. Project L's IRR project L's IRR is 13.55%. Right? So we can solve this question very easily by if you use the Excel spreadsheet. So project L's IRR for project L is 30.5%. IRR for project S is 14.49%. So the rationale for IRR method, the rationale for NPV method is okay only if NPV is higher than the 0, right? If the project net present value displays a positive number, then we can accept if the project are independent, right? Or if projects are mutually exclusive, then we need to choose the project whose net present value is the higher, right? how come in the IRR's rationale for the IRR method is if the IRR is higher than the double ACC, so double ACC play a role as hurdle rate to make decision. Okay, so if IRR is higher than double ACC, then the project's return exceed its cost. IRR is the return, right? Return, internal rate of return. Double ACC is cost. So if return is higher than the cost, then here is some return left over to boost stockholders' returns. So if IRR is higher than double ACC, we can accept the project. Whereas if IRR is lower than project, double ACC play a role as the hurdle rate, then we can reject the project. Right? So simple. Okay. So in this example, we assume the AACC is 10%. So the project L is IRR, project L S the IRR, both the projects IRR are higher than the 10% AACC. Okay, so if two projects are independent, then we can accept both of them. Whereas if projects are mutually exclusive, then we can accept the highest IRR's project. So IRRS for project S is 14.49%. Project L's IRR is 13 point something, right? 13.52. 13 point 13.55, right? 13.55. So which one is bigger? Which one is higher? S is higher. Okay. So it's conflict, right? So if we use NPV, then what? If we use NPV, which one is better? Project L is better, right? NPV, here you go. If we use the NPV for project L is higher than the NPV for project S. Okay, so if we use the NPV, we should choose project L if the projects are independent, they're mutually exclusive. But if we use the IRR, then IRR for project S is higher than IRR for project L. So there is conflict, right? When we use NPV, project L is better. We need to choose project L. When we use the IRR, then we need to choose project S. What should we do? Which one we should use, NPV or IRR? Which one is better to make decision? Or is conflict? Or L, we should choose L or S. When you use the NPV, L should be chosen. When you use the IRR, S should be chosen. Then what should we do? What should I do? So which one should be used? NPV or IRR? 준서. 네. 준서. 네.
Yes, Professor.
준서. Yeah. Which one should be used? NPV or IRR?
Honestly, I don't know.
Honestly, you don't know? Then 그러면 dishonestly는 뭐야 그러면? If you read the teaching material in advance, I think you can have the solution. NPV or IRR, which one is better? 안 읽었어. You didn't read teaching material.
Sorry.
Which one should be used? Mark. MPV or IRR? 50-50.
Wait, I'm still thinking.
Just thinking. 장욱이, 윤영호. Which one should be used? NPV or IRR if there's a conflict? IRR? 이상해. It's very weird. The probability is 50-50, but all of the answer you did is the wrong. NPV, right? Yeah. All of you guys didn't read the material in advance. 뒤 나오잖아. 그 바로 나오잖아. The next topic is what? Problems with IRR, right? Problems with IRR. Multiple IRR, reinvestment rate assumption 나오잖아요. So if there are conflict when we use IRR and NPV, we should use NPV. Okay, NPV. Why is that? As I told you, most of decision maker use both of them, NPV and IRR. But in some way, IRR is easier to understand method, right? So just IRR, the 14%, 13%, definitely 14% is better, right? So it's easier to understand, okay? But if we use the IRR, then IRR has a lot of problems to use, okay? A lot of problems. So right after this PowerPoint, just problems with IRR 나오잖아. Problems with IRR. So even if decision maker used to use IRR, but if they want to use IRR, then be careful with several the things, just like that. Okay, so let's take a look at the problems occurs if we use the IRR, just like that. So if project is independent case, project are mutually exclusive case. Let's take a look at each by one, each one by one. So let's take a look at the project are independent. If project are independent, first one is we first think about that project is sort of investing project or financing project. In other words, most of project we will consider or we considered is investment project, right? So investment project generally cash outflow first as capital expenditure and cash inflow later on. So cash inflow is followed by cash outflow in investment class. First of all, we need to spend some money and then we need to receive the cash until the duration of project. Okay, cash flow stream of financing project is reversed with the investing project, which means cash inflow occurs first and then cash outflow is followed by cash inflow. In financing case, most representative of financing project is just like you like BTS, right? Bangtan, 방탄 in Korean. 왜 방탄이 bangtan 있어? The exact pronunciation is 방탄, but most of the foreigners pronounce bangtan, right? Bangtan, right? Bangtan 소년들. So let's think about the performance of Bangtan BTS. Then what kind of things happen first? The cash inflow, cash outflow. They sell tickets. right? So cash inflow occurs first. Cash inflow happened first, and then the entertainment company should pay the rent fee for location, or they should pay the performance fee to the Bang Tan, so then, right? BTS, right? So in financing project, the characteristic of financing project display the reversed cash flow stream. So cash inflow happened first. Cash outflow is followed by cash inflow, whereas investing project, cash outflow happen first, and then cash inflow is followed by cash outflow. So cash flow, direction of cash flow stream is reversed in investing case and financing case. So if investing case is okay if we use the IRR, but if financing case, when we use IRR, then most of the times IRR display the negative, minus, right? So for example, IRR is the negative minus 10%, IRR is negative 12%, for example. Okay, so in the financing project, generally IRR provide a negative percent. Then if we compare negative 10%, negative 12%, then negative 10% is better, looks like. Okay, but if the IRR for project S is 10%, IRR project L is negative 12%, then negative, the higher negative, the better. So it's very weird decision procedure. Okay, so if you want to use the IRR, then you should recognize that whether a project is investing or financing, how the cash flow stream happen, cash outflow and cash inflow, or cash inflow and cash outflow. Okay, that's the one problem when we use IRR if the project is independent. So you should make sure. So this one is pure method. So I let you know how can we cure those kind of problem when we use IRR. So if the project is confused, is wondering the project is investing or financing, then you should make sure whether the project is investing project or finance project. That's the first problems when we use the IRR if the project is independent. And second problem is what? We may be able to get the multiple solution, multiple IRR. So for example, so as I told you, there are two types of cash flow stream, right? The normal cash flow stream and non-normal cash flow stream. Normal cash flow stream is the one time change of sign. Non-normal cash flow stream is the more than twice change of signal, right? Sign. Okay. So multiple IRR minus 1.6, 10, negative 10. There are 2 years project, minus 1.6, 10, minus 10, right? So sign change one time, sign change twice, two times, right? So 2 times sign change. This is called as non-normal cash flow stream. So if the sign change more than 1 time, this is just a 2. We may have multiple IRR, more than 2 IRRs. And which one is real IRR? Which one should be used? That's the we are wondering. Okay, so here you go. So if IRR has more than 2 multiple IRR, then we can cure those kind of problem by using MIRR, modified internal rate of return. As you can see, modified internal rate of return. Here you go. This is a non-normal cash flow stream, okay, minus 1.6, 10 minus 10, this example, right? So when we start this project, we should pay 1.6, and 1 year later, we can expect a 10, and 2 years later, we can expect negative 10, okay? So 1 minus 1.6 plus 10 divided by 1 plus IRR minus 10 divided by 1 plus IRR square is going to be 0. So we can calculate, we can solve this IRR. You can solve these questions because this is quadratic, right? This is quadratic. So minus b plus minus root 2b square blah blah 4 minus 4ac minus blah blah, you know, right? The equation for the root equation, we would say, right? Is the quadratic. So if we solve these questions, IRR, this is quadratic equation, IRR may be 25% or 400%. And which one is better? Which one is real IRR? Just looks like 25% is better, right? 400% is unrealistic. 25% is rare. But still, we have another IRR, 400%. Then which one is the real IRR? We do not know. Both of them, right? So if we make graph, this cash flow stream, x-axis is WACC, y-axis is the NPV. Then if WACC equal to 0, then it's 0. Then all of denominator is 0. Then just the sum of minus 1.6, 10 minus 10. Then the remaining one is minus 1.6. If we sum of all kind of things, regardless of time value of money, then the answer is minus 1.6. So this is minus 1.6. 1.6, right? So if the WACC is equal to 0, then the present value is minus 1.6. So if as WACC increase, the NPV is increase. So we also already defined what IRR is the discount rate that what makes NPV equal to 0. So if this NPV touch the x-axis, then this is the IRR, because we defined the IRR as the discount rate that makes NPV equal to 0. Okay, so as WACC increase, then reference values increase until 20%, 30%, 40%, something like that. After that, the NPV start to decrease, and then we have another point to touch the x-axis, the intersect the x-axis, which is the 400%. So because we defined the definition of IRR is the discount rate that makes the NPV equal to 0. So 25% or 400%, both of them are solution, not IRR. So we have two IRRs, right? Then which one is which one is the correct answer? 25% or 400%? We do not know, right? So if we have multiple IRR, then what should we do? Then what should we do? Then what? We can use MIRR, the modified internal rate of return. As you shall see, right? That's the second problems when we use IRR. And even if the project are mutually exclusive, we also face some of the problems when we use the IRR. Scale problem or time problem. Scale problem is just like that. If project S, we start the project S to spend the $10, and we can receive $2, $3, $5, $6, for example, cash inflow, just like that. But another project we consider is the project L, but project L need $1,000, and we can expect $200 at time one, $350 at time two, $550 at time three. Then the size of L, cash flow and cash outflow, is about 100 times comparing to time the project S. But if just like two mutually exclusive projects have just a huge difference of scale, then if we use IRR, then it's gonna be problem. It's gonna be very weird. You can figure out very weird solution. So if two projects have the big difference in the cash flow and cash outflow, the size, then we should match the scale. That is the solution, right? Cure method. So real cash outflow is 10, but if we want to compare project L, then we can multiply by 100 to the project S. So it's gonna be 1,000, 200, 300, 600, so it's like that. So if two projects have big difference in terms of scale size, then if you use IRR, it's gonna be a problem. Okay, that's the third opportunity problem. Fourth problem is timing problem, just like our example. So project S, in project S, the most of cash inflow happened all your time during the project, right? Whereas in project L, a lot of the money, we can receive a lot of money in later time of the project. So if we use the IRR with this kind of difference is the timing, then it's gonna be problem as well. So it's gonna be a problem as well. So if there's some problem, if there are some timing differences, then we can use not IRR. Instead of IRR, we can use the IRR, incremental IRR. Okay, so I introduced some of the problems when we use the IRR, and then I also provide the cure method in each problem with IRR. Okay, so let's take a look at one by one. Multiple IRR, I already explained that one. So why we have two IRRs? And why is the big difference between IRR and NPV? This is the crucial reason why we have two IRRs, multiple IRRs, if the sign non-normal cash flow stream, or the big difference between the assumption, the assumption of the IRR and the NPV is the reinvestment rate assumption. Okay, this is the most difference between NPV and IRR is the reinvestment rate assumption. Assumption for reinvestment rate is totally different in NPV and IRR. So as I told you, NPV method assume the cash flow are reinvested at the WACC, whereas the IRR method assume the cash flow are reinvested IRR. That's the most crucial different point between NPV and IRR. Okay, so in NPV, we assume the WACC is used as discount rate simultaneously. We assume that WACC is reinvestment rate, right? Whereas in IRR, the IRR, we can discount the overall cash flow stream by using IRR. Simultaneously, IRR can be used at the reinvestment rate. Okay, so NPV at IRR, IRR at IRR, right? Okay, so then which one is more realistic? Which one is more logical, rational? Assuming cash flows are reinvested at the opportunity cost of capital. From the point of perspective of opportunity cost of capital, you're familiar with opportunity cost, right? So when we talk about the retained earnings, so even if retained earning is our money within the company, but if we use the retained earning, we should recognize that the retained earning as the cost. In that context, cost is opportunity cost, right? So even if we do not use directly, but if we use that one, then we should consider those kind of money as opportunity cost by the same token. Same thing. So assuming cash flows are reinvest, opportunity cost of capital is more realistic, logical, rational. So NPV method is the better. Here you go, the answer, what I'm asking, right? NPV is the better. Right? NPV method is the better rather than IRR. So another, the unrealistic assumption of IRR is that one. So, the meaning that we discount IRR can be used as discount rate means what? We can use the IRR as the reinvestment rate, right? But for example, cash flow 1, cash flow 2, cash flow 3 at time 3, if we assume there are 3 years project, okay, then according to the IRR, cash flow at time 1 can be reinvested at the IRR, right? But this IRR, we do not know at time 1. IRR. At time 1, we do not know what IRR is. At time 2, we do not know IRR. Then how can this cash flow stream reinvested at IRR? It's impossible, right? It's illogical, irrational. There's another reason why IRR, we cannot use IRR as the reinvestment rate. Okay, so NPV method is better. So NPV method should be used to choose between mutually exclusive projects. All right, so if we have the conflict between the result of NPV and result of IRR, then we should use the NPV result. Okay, so perhaps a hybrid of IRR that assumes cost of capital reinvested needed. This hybrid of IRR is MIRR, okay, modified internal rate of return. So the cure method is what? We assume it's okay if we assume the reinvestment rate is not IRR but WACC, just same as the NPV, then it's okay, right? So finally, ultimately, even if we used IRR, but if we assume that cash flow during the project can be reinvested at not IRR but WACC, then it's okay, right? Then we may be able to use IRR as well. Okay, that method is called as MIRR, modified internal rate of return. Then here's the example here. What is the MIRR, modified internal rate of return? MIRR is the discount rate that equals the present value of project's terminal value to equal the present value of cost. Terminal value is found by compounding inflows at not IRR but AACC, which means we assume cash flow stream, cash flows invested at not IRR but AACC in MIRR. Okay, in MIRR. So MIRR assumes cash flow are reinvested at the AACC, not IRR. Therefore, MIRR can avoid the multiple IRR problem. Here is the example. Here, the managers like rate of return comparisons, and MIRR is better than IRR. So here's the example. Here's the project S cash flow stream originally, minus 1,000, 500, 400, 300, 100. Okay, so in IRR we assume this one reinvested at IRR, but if we change our assumption, the reinvestment rate is the not IRR but from IRR to the AACC, then this 100 that happened at time 4 is 100 at time 4. We are here now. We can calculate the value as of the end of this project. This 300 is going to be 330. This is 300 times 1.1 because the AACC is the 10%, right? For example, project S is the IRR is 14.49%. So in IRR, original IRR, this is assumed to be what? 300 times 1.1449. 1449. Okay, but we do not calculate the one. Well, we do not calculate the 300 times 1.1449 instead of 1.1449 instead of 1.1449. We can use 1.1 as AACC. It's going to be 330. And 400 times 1.1 square, 1 year, second year, first year, and second year, 2 years, right? So 400 times 1.1 square is 484. 500 times 1.1 to the power of 3, 1 year, 2 year, 3 years, is going to be 665.5. So if we sum up all kind of cash flow as of the closing period, the project is gonna be $1,579.5, right? So all of the cash inflow, calculated value as of the ending period, closing period. Then now we can use the IRR logic now. Okay, IRR, we already defined IRR. What's IRR? IRR is discount rate that makes the NPV equal to 0, right? So NPV minus $1,000, and all of cash flow happening at time 1, time 2, time 3, move to time 4. So time 4, the cash flow at time 4 is 1,579.5 divided by 1 plus MIRR to the power of 4. 1, 2, 3, 4. So basic logic is the same as the IRR, right? IRR. But the only difference between MIRR and IRR is what? We can assume cash flow stream at cash flow at the happening at each year reinvest at not IRR but AACC. That's the only different point. Okay, it's gonna be 0. This is the MIRR. So if we move the minus $1,000 in left hand side and right hand side, then 1,579.5 divided by 1 plus MIRR to the power of 4 equal to 1,000. Okay, so if we solve MIRR, then MIRR for project S is 12.1%. 12.1%. By the same token, project A's MIRR is 12.7%. Now, if we use NPV, L is better than S. If we use IRR, S better than L, right? But if we use MIRR now, which one is higher? MIRR for project S or MIRR project L? MIRR for project L is better than MIRR project S. So MIRR is the L is better than S. So if we compare the NPV now, there's no conflict. Okay. So instead of IRR, if there's some problem, multiple problem, sign change of problem, then we may use the MIRR instead of IRR. Then MIRR is superior to IRR? Yes. Yes. Because the reinvestment at the cost of, we assume the more logical, more the rational assumption, not IRR, but the AACC, okay? And the MIRR is the sort of solution, provide solution for multiple IRR. Then, MIRR is as good as NPV? The answer is still not at all, right? Not at all. I kind of think in size problem, life of length problem. As I told you, if two project has different size, then if we use MIRR, still we cannot cure the size problem if we use MIRR. Still this size problem cannot be solved even if we use MIRR. And another problem is life of length. Life of length is just like that. Project L, project S is a 3 years project. Project L, 10 years project. Then if we compare simply by these two projects, then it's gonna be problem even if we use MIRR. Okay, even if we use MIRR, there is still some problem. So MIRR is better than IRR, but still inferior than NPV. Okay, NPV. That's the I introduced the cure method of this multiple IRR, MIRR. Okay, and the next topic is what happened if there's some timing problem, just like this our example SN, the project S and project L. So as I told you, project S, we can receive the money earlier, more money in earlier time, whereas you can receive the the money in later time in project L. Then how can we solve these kind of problems? That's called as timing problem. But this is really complicated, so I will explain this issue in next class. Okay, any question? All right, then if 평균 얘기해줬지 아까. 내가 평균 얘기해줬지. 혜진. Average is 55.55. Median is 68. So median is much important than the average because basically your grade is determined by relative score, not absolute score. But normally I combine the relative score and the absolute score. Okay. So if you do not have any questions about midterm exam quiz and homework, then you can log out now. But if you have the questions about midterm exam or some the homework and quiz, then you can stay. All right. See you on coming Tuesday. All right. So anybody who do not have any question, you can log on now.